Hey guys, Mr. Mathwiz here with our part 2 on lesson 5, which we were talking about scaling and scale factors. So yesterday we talked a lot, we were just kind of an introduction. Yesterday we talked about what scaling is. We talked about how scaling means that something is either increasing in size or decreasing in size, and that it has to do so proportionally. And we talked about scale factors. A scale factor is telling us how much it's increasing or decreasing by. So today I want to keep on that, but I want to show you more of the mathematics behind it. So when we write a scale factor, it's usually written as a ratio. So for instance, if I had a scale factor of 1 colon 2, the 1 here represents my original, and the 2 represents my new. So this is implying that whatever I have, it's doubling, right? So this would be, if the original was 10 inches long, the new would be 20 inches long, things like that, right? So for every one of the original, there's 2 of the new. If you were to do this as a fraction, you'd be looking at 2 over 1, because you're doing the new over original, because that's the way we've been doing it in class. That's the standard, new over original, right? And then if you return that into a percentage, you would get 2 divided by 1, which is just 2, and you'd move that decimal point 2 places, and it becomes 200%. So you could say that it's a scale factor of 200%, meaning that it's doubled. But the one over here, the 1 to 2, is really the more common way to see it. When we're talking about scale factors, they're usually written as a ratio. All right, so how does that help you? How does this work? So let's say let's go back to the maps, because we were talking about maps a little bit yesterday. Let's say you want to know how far away something is, and you have a map, and it has a scale on it, and the scale lets you know that for every, let's say you measured the little scale there, and it turns out to be an inch and a half. So the little scale is an inch and a half long, and it tells you that that inch and a half represents 50 miles. Well, then you get your ruler out, and you measure something, and you find out that the place you want to go is 5 inches away on the map, right? So obviously, your destination is not literally 5 inches away, so you want to know how far is it. Well, if every inch and a half of the map is 50 miles, and you have 5 inches, you're looking for that missing mile. So this is set up like a proportion, which you guys should be very used to seeing by now, because we've done a lot of these. And then when you do this, you can multiply across with the one we call the butterfly method. You multiply across, and you divide the leftover piece. So x would equal 5 times 50 divided by 1.5. And then we would get our answer. So 5 times 50 divided by 1.5, 166.666. So that would be 166.7 miles. And there we have it. So here we were able to use the scale on the map, which would have looked something like this. It would have had 50 miles, and this distance here would have been equal to, that distance here would have been equal to about an inch and a half, right? So that's how we figured out the mileage on our little destination, right? So this is super helpful. If it's not on maps, the scales look like this, and you should have seen that video yesterday. If we use the ratio that we talked about, it's very common when things are written as a ratio for the first number to be 1, especially if you're increasing, which in most cases is what you're doing, because most scales are going to be significantly smaller than the actual object, right? It wouldn't make a lot of sense to make an object really, really big unless the original object was super small. So in most cases, it's going to be, the 1 is going to be in front to signify that you're getting bigger. So if I had a model train, it might be a scale of 1 to 200. Maybe I have a really small train, a really small model, and the real train is much bigger. So it could be a scale of 1 to 200. And then if I measure the height of that train, and the height of that train is a quarter of an inch, right? So we'll say 0.25 inches. Well, I want to know how tall the train really is. Well, I can use the same ratio. Well, actually, I don't even need inches up here because it's just 1 to 200. It doesn't matter the units when you're using the scale. That's actually an important thing I should probably mention. Notice my scales, the 1 to 200 or the 2 to 1 that I had up, or 1 to 2 that I had up there, they don't have units. It's because the units don't matter. If you're talking about inches, feet, centimeters, they all are going to be increasing at the same rate, okay? So, and then in this case, I've got that. So all I'd be doing is multiplying 0.25 times 200. Now, if I'm thinking about my proportions, if I'm using my butterfly method, I'm then dividing by 1. But we all know dividing by 1 doesn't really do anything. It doesn't really change anything. So my final answer is 200 times 0.25, which should come out to 50. Which is about really short. So that was probably a bad indication because the train should definitely be taller than that. That's what I get for trying to pull numbers out of my head. But yeah. So if you have a scale factor, you can use it to figure out the real information. So in this case, we were trying to get something that was small and we were trying to figure out bigger. It could go the other way. So if you had, let's say you had a model, a very large, or a large picture. Ooh, this is a good one. Let's say you got a large picture of an insect, something that is much smaller in real life. It might say that the scale is 500 to 1, meaning that the real insect is much, much smaller. So then you could use that, you could measure it, and you could figure out how big it really is by doing proportions. So you put 500 to 1, and then whatever you measure on the picture, you'd put here, right? So if you measure something, and it looks like it's 10 centimeters when you measure it, well then in real life, it's going to turn out to be 10 divided by 500. Because 10 times 1 is 10, divided by the 500, and that's how big it would actually be. Let's see here, what is that? 10 divided by 500 would give you 0.02. So now you know it's 0.02 centimeters, right? So that's kind of the math behind the ratios and the math behind scaling. It's not complicated stuff. You're just using proportions the way you have been. Just make sure you remember to keep track of what goes on top and what goes on bottom, right? So if you're decreasing in size, then the larger number is going to go on top with your measurement. If you're increasing in size, then it's going to be the smaller number that goes with your measurement, right? They have to be related. So either the smallers are going to go on top and the largers are going to go on bottom, or vice versa. But make sure you draw your proportion correctly so that your answers make sense. All right. For this lesson, for lesson 5, the activities in the lesson are super helpful. There's several of them. I know yesterday we should have gone over the getting started and activity 1. Really, in class today, you should be going over activity 2 and 3 and maybe touch on 4. If for some reason we don't get through those, I highly recommend you do them on your own. They're great activities. They're great practice. They really help you understand the scales and how all that works. So if we don't get anything we don't get done today, I would recommend looking at over the weekend. And then next week, we'll touch on it a little bit more and we'll do some reviewing for the whole unit, because I know it's a really big unit and I want to make sure you guys remember everything before we test at the end of the week. All right. Have a great day. Have a great weekend. I'll see you later. Bye.